Lesson: AI system vulnerabilities and threat modeling. Artificial intelligence systems are increasingly integrated into various aspects of daily life and business operations, offering unprecedented efficiencies and capabilities. However, as these systems become more ubiquitous, they also present unique vulnerabilities that require rigorous threat modeling to ensure security and reliability. Understanding AI system vulnerabilities and implementing robust threat modeling frameworks are crucial for professionals aiming to safeguard these systems against potential threats. AI systems, by their nature, depend heavily on data inputs and algorithmic processes, making them susceptible to specific types of vulnerabilities. One primary concern is the integrity of the data used for training and decision-making. Adversarial attacks, where maliciously crafted inputs are used to deceive AI models, highlight a critical vulnerability. For example, a study by Goodfellow et al. Demonstrated how slight perturbations to input data could cause misclassification in image recognition systems. These adversarial examples exploit the model's sensitivity to input variations, posing significant risks in applications like autonomous driving and facial recognition. Moreover, AI systems often operate as black boxes with complex and opaque decision-making processes. This opacity can mask potential biases and errors, leading to unintended consequences. Bias in AI systems is a notable vulnerability as it can perpetuate or exacerbate existing societal inequities. A high-profile case involved a hiring algorithm developed by a tech giant that, unbeknownst to its creators, discriminated against female applicants. Such biases are typically introduced during the training phase, where historical data reflecting societal prejudices are used. To address these vulnerabilities, threat modeling offers a structured approach to identifying and mitigating potential threats to AI systems. Threat modeling involves understanding the system architecture, identifying potential threats, assessing the risks associated with these threats, and implementing measures to mitigate them. One effective framework for AI threat modeling is the STRIDE model, which stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. STRIDE provides a comprehensive checklist to evaluate threats systematically and develop countermeasures. In practical terms, implementing threat modeling in AI systems requires a multidisciplinary approach involving data scientists, security experts, and domain specialists. A step-by-step application of threat modeling begins with mapping the system architecture to understand data flows and access points. This stage is crucial for identifying where vulnerabilities might arise, such as interfaces where data is ingested or processed. Next, professionals should employ tools like Microsoft's Threat Modeling tool, which facilitates the visualization of system architecture and automates threat identification based on predefined templates. Following the identification of potential threats, risk assessment is the next step. This involves prioritizing threats based on their likelihood and potential impact. For example, adversarial attacks in a healthcare diagnostic AI system present a high risk due to the potential for misdiagnosis, necessitating immediate attention. Risk assessment frameworks such as CVSS can be adapted for AI contexts to quantify and compare risks systematically. Once risks are prioritized, implementing mitigation strategies becomes the focus. Techniques like adversarial training, where AI models are exposed to adversarial examples during training, can enhance model robustness. Furthermore, employing explainability tools such as LIME or SHAP can help uncover biases and errors in AI decision-making processes, thereby addressing the black box issue. These tools provide insights into how models make decisions, allowing for adjustments to training data or algorithms to mitigate biases. Case studies underscore the importance of these strategies. One notable example is the use of adversarial training in cybersecurity systems. Researchers at MIT developed a robust AI model for network intrusion detection that was less susceptible to adversarial attacks by incorporating adversarial samples in its training data. This approach not only improved the system's resilience, but also highlighted the practical application of adversarial training in enhancing AI security. Statistics further illustrate the need for robust AI security measures. According to Gartner, by 2022, 30% of cyber attacks on AI systems will leverage training data poisoning, model theft, or adversarial samples. This prediction underscores the urgency for implementing comprehensive threat modeling and mitigation strategies in AI deployments. In conclusion, addressing AI system vulnerabilities through effective threat modeling is imperative for ensuring the security and reliability of these systems. By understanding the specific vulnerabilities associated with AI, such as adversarial attacks and biases, professionals can employ structured frameworks and practical tools to identify, assess, and mitigate potential threats. The integration of adversarial training, explainability tools, and rigorous risk assessment frameworks can significantly enhance the resilience of AI systems. As AI continues to permeate various sectors, the ability to safeguard these systems against evolving threats will remain a critical competency for AI implementation professionals.